Hey everyone, and welcome. Today, we are going to tackle one of those really clever features in Java that, I'll admit, looks a little weird at first, but trust me, it's incredibly powerful. We're talking about the anonymous inner class.
So let's just jump right in. Have you ever been coding along and run into this exact situation? You think, I have this one object, and for this single object, and only this one, I really wish one of its methods did something completely different. Well, guess what? That's the exact problem we are going to solve today.
Now, to really wrap our heads around this, we're going to start with a classic programming scenario. It's super simple, but it perfectly sets the stage for the cool stuff that's coming up. Okay, so let's start with something incredibly basic. Here we have class A. Inside this class, there's just one method. It's called show, and all it does is print out the words in a show. That's it. Super straightforward, right? And as you would totally expect, when we create an object from class A, we'll call it obj, and then we call that show method on it. What do we get? In a show. No surprises there. This is our baseline, our normal behavior.
Okay, but here is the big question. What if, for this specific object we just made, we want the show method to do something else entirely? We don't want to change the original class A because then all future objects would be different. We just want to change it for this one instance. How in the world do we pull that off?
Well, if you've been working with Java for a while, your brain probably jumps to one immediate conclusion. The classic, by-the-book approach. Just create a subclass.
Yeah, this is basically method overriding 101, isn't it? We create a whole new class, let's call it B, and have it extend our original class A. By doing that, B inherits everything from A, including that show method, which we can now change to our heart's content.
And here's what that looks like. Inside our new class B, we write our own version of the show method. We've overwritten it, so now it prints in B show. And boom, we have a class that has the special behavior we wanted. Problem solved, right?
Well, let's look at what happens behind the scenes when we compile this. The Java compiler sees two classes, A and B, so it creates two separate files, a.class and b.class. Just keep that in the back of your mind for a second. Two classes, two files.
So here's the thing. This works, it totally gets the job done, but is it efficient? We've created an entire new named class, B class, which adds another file to our project. And remember, we only needed this special behavior once for a single object. Creating a whole new class for that feels like a lot of work. It's kind of overkill.
And this is where a much more elegant, much more direct solution comes into play. It's perfect for this exact one-time use situation. Let's pull back the curtain on the anonymous class.
So, what if we could do something different? We start creating our object like normal, new A, but then, what if, right before that final semicolon, we just opened up a pair of curly braces? What if we could define our new, custom implementation right there, on the spot?
And that is the whole idea. What we've just created is an anonymous inner class. Think about it. It's a class that has no name. It's literally anonymous. We are defining a new class and creating an object from it all in one single step right where we need it. It's the perfect tool for a one-off job.
Now, here's what's so cool. Even though we didn't give this class a name, the Java compiler still needs to create a .class file for it. But look at what it does. It gives it a name like demo$1.class. That $sign is a hint that it's an inner class, and the 1 is just the compiler's way of keeping track. It's like a secret nameless class. I know. That syntax can look a little intimidating the first time you see it. But let's break it down step by step. It's actually way simpler than it looks, I promise. Okay, let's walk through it. First, you start out writing code just like you're creating a normal object. A_obj equals new A_ob. Easy. Second, and this is the magic part, you stick a pair of curly braces right after the parentheses, just before the semicolon. And finally, step 3, inside those braces, you just go ahead and write the method you want to override, giving it your new code. That's all there is to it. You've just made an anonymous class.
So you might be sitting there thinking, okay, that's a neat little trick, but it is so much more than that. Understanding this concept is actually fundamental to understanding a lot of modern Java.
I mean, this table really says it all. A named subclass like our class B is great when you've got some complex logic that you know you're going to reuse over and over. But for that single, one-off change, the anonymous class is way more concise. It keeps the logic exactly where it's being used, and it doesn't clutter up your project with extra files. And here is why this really matters today. This whole idea of defining a little piece of behavior on the fly, well, that's the direct ancestor of Lambda expressions, which are a massive part of modern Java. In fact, if you've ever written an event listener for something like a button click in a UI, chances are you've already used an anonymous class, and maybe didn't even realize it. It's a foundational building block.
So if you're going to take away just one thing from all this, let it be this simple definition. An anonymous class is really just a shortcut. It's a clean, quick way to define a one-time use class and create an object from it, all in a single expression.
And that brings me to my final question for you. Now that you've seen this awesome shortcut, I want you to think about your own code, your own projects. Where could you go in and replace a clunky, single-use subclass with a clean, elegant, anonymous inner class? It's something to think about. Thanks for tuning in.